Using microseismic data for unconventional wells. The objective of this example is to illustrate how microseismic event data can be interpreted in terms of fracture geometry along a fractured horizontal well and how it can be utilized in building a complex numerical model in Topaze. A microseismic survey was run during the frac job, and the microseismic data is available. A multi-fractured horizontal gas well with a lateral length of 4,500 feet is considered. The fracture stimulation design assumes 26 fractures and an expected fracture half-length of 500 feet. Other reservoir parameters are entered manually. Generate an initial analysis. A good match is obtained using the initial parameter estimations. A new analysis is created, called numerical linear, and the parameters of a simple, multi-fractured horizontal well are taken from the analytical model. Prior to generating the numerical model, in the Map tab, define the boundaries as a rectangle that bounds the multi-fractured horizontal well. Return to the Analysis tab and proceed to the Numerical Model dialog. Initialize it using Reset from Analytical. A satisfactory match is obtained. In the next step, a complex fracture geometry utilizing the available microseismic data will be defined. Create a copy of the previous numerical analysis. Go to the Map tab and double-click on the well to open the Well Definition dialog. Toggle on the Microseismic option to launch the Loading Microseismic Data dialog. There are some default microseismic attributes already selected: X, Y, TVD, date, and time. Other built-in attributes, including stage index, magnitude, and amplitude, are present. In addition, user-defined attributes can be added to the list. Click on the Add button to add new attributes, SNR and Semblance. Tick on Semblance, SNR, Stage Index, Magnitude, Amplitude, and strike to be loaded. Click OK. The Load dialog appears. Browse to select the appropriate file. Change the units for X and Y to meters and keep TVD in feet. Define the attributes and the proper units for each column of the incoming file. Once all columns are defined, click OK. Close the dialog to hide the displayed microseismic events. Change the well modeling type to Complex. Enable all possible options for individual fracture properties for maximum flexibility in geometry definition. Display the microseismic events by ticking on the microseismic icon. Select Amplitude as event size and adjust the base size. Zoom into the well and adjust the geometry and position of the fracture according to the microseismic event display. Due to the uncertainty in the microseismic event interpretation, multiple well geometries can be found to match the microseismic data, and several attempts may be necessary until reaching a good match. The total fracture half-length found from previous analysis steps can be used as a constraint to select a reasonable interpretation. Validate the fracture geometry by clicking OK. In the Analysis tab, select Numerical Model. The geometry of the complex horizontal fractured well is shown and can be adjusted in this dialog. Generate the model. On the 3D plot, the pressure along the fractures can be played back. The microseismic data can be added to the display with the values of attributes reflected in size or color of the events. This concludes this video on using microseismic data for unconventional wells.